I'm Professor Lucy Rogers, the inventor with a sense of fun. I've judged fighting machines on Robot Wars, written a book on rocket science, and even performed stand-up comedy. But now I have a new challenge. Design Spark want me to find out how everyday tech is helping people and places do extraordinary things. From saving bees to unlocking a sixth sense. Just how are they giving themselves the engineering edge? I'm out in my workshop and it's absolutely freezing. It's, early evening, but it's already dark and I can see the moon waving at me through the open doors. I'm not actually sure it's approving of my latest project, which I just can't seem to get right. I need to persuade this bit into there. Okay, that didn't work. Time to order a new tool from the internet. It should be here tomorrow. Ah, that's my producer, Tiffany. That's a good excuse to stop. Hi, Tiffany.
Hi, Lucy. Working on one of your top secret space projects again.
Yeah, but everything I'm touching is breaking, and I feel a lot less like Scotty from Star Trek and more like Sir Kill-A-Lot.
Don't be so hard on yourself, Lucy. Scotty had a lot of advanced tech helping him out.
Yeah, he could just replicate anything he wanted immediately.
That would be so useful. Although, technically, astronauts can almost do that today.
You what? How?
So I heard that 3D printing is becoming an important part of space travel and is a piece of everyday tech that could help take us to the moon.
Really? Hang on, why would astronauts need 3D printers?
Well, I think you should make that your mission this episode and find out.
Okay, I'll give it a go. I should probably clean this up first. The thing about space travel is that you can't easily pop to the shops when something breaks. You can only use what you take with you. And there's no ordering up tools over the internet for next day delivery. Except there might be a way you can do just that. I've been doing some research and found a company that's installed a 3D printer on the International Space Station. And with this printer and a connection back to Earth, they're starting to do things that have the potential to revolutionise the way we live and work in space. I've decided to call Matt Napoli, the Vice President of In-Space Operations for a company called Made in Space. And I'm calling him at his home in California. Hi, Matt. It's so great to take the opportunity to chat with you today.
Hi, Lucy. Yeah, me as well.
I've heard about this 3D printer on the International Space Station. What's it look like? How big is it?
The latest one is about the size of a microwave. So pretty compact. As with most things in space, size is a valuable resource. So we try to make all of our systems as small as possible.
Who's using it? How's it being used?
We use it for a variety of customers, our largest being NASA. So we do a lot of science with them to understand what does microgravity do to items manufactured in space. And then there's more practical uses as well on top of that, where if the astronaut needs a tool or a part for, one of the other experiments on station, we can digitally deliver them parts on demand.
So you're teleporting stuff up, really?
Yeah, we actually have our mission control center here on the ground. We call it Digital Launch Complex because we can digitally send physical items to space.
And they're using recycled materials on the ISS. How's that working?
We have a new project. It's kind of a sister payload to our 3D printers that's meant to recycle a plastic and reprocess it into feedstock that we can then put into our 3D printer, really creating a closed-loop, sustainable ecosystem where we're not relying on material from the ground. We rely on material that's already in orbit.
So you're printing stuff. When you're finished with it, you're taking it, chopping it up and shoving it back in?
We also realized as we were developing the product, there's a ton of plastic waste on the space station. Most items that get launched to orbit are wrapped in bubble wrap, wrapped in plastic, and wrapped in polymer foam. And all that just becomes trash. It's not really needed anymore once the packages get to space.
So just like a package that comes to my house that's all wrapped up in the bubble wrap.
Right, exactly.
When packages are sent up into the space station, they're also wrapped.
Exactly, yeah. To survive the launch loads and the vibration, it's needed. But once an item's in space, it's just floating there and the bubble wrap is overkill. So we've actually worked on turning those plastic bags and the plastic bubble wrap into feedstock and then printing with it as well.
What other materials have you been learning to print with?
One of the things we're diving into, and we're going to have an experiment on the space station next year, is looking at in situ resource utilization. What that means is using the resources in space. And this first project is going to be to use moon dirt, lunar regolith.
Oh, wow.
And use that as a construction material. We're going to demonstrate essentially 3D printing with moon dirt and a binder to hold it together to develop tools, and eventually this leads us on a roadmap of building kind of construction scale facilities on the moon, infrastructure like landing pads, roadways for rovers, habitats for rovers, and eventually humans.
So I'm just trying to get my head around that. So you're hoping to take a 3D printer eventually onto the moon, use the moon dust to make your roads, make your buildings, make the launch pads.
Yeah, exactly. We've been developing the technology for 7 or 8 years now already, and can do quite a bit here on the ground on Earth. It's just a matter of adapting it to the moon and getting a ride to the moon.
Wow. But you've also put 3D printers on satellites, I believe.
Yeah, so another avenue we're exploring is kind of the same reason we're thinking of building on the space station and on the moon and taking that to satellites and autonomously 3D printing parts of satellites. And the reason we're looking to do that is to make much more capable satellites, much larger satellites. So the idea with our first demonstration mission called Astronaut is to 3D print a solar array much larger than a typical solar array can be deployed from a satellite. It's going to print a 10-meter long boom, and then a solar array is going to be rolled out from that boom. And this technology we've developed, it's essentially a 3D printer that can print in one direction sort of infinitely long. And here on the ground, we've used that technology to build the world's longest print. It's 122 feet long. We have the Guinness World Record for the world's longest print. It's just this beam that went the whole length of our building.
Wow.
So the idea
was restricted by the building, not by the machine.
Yeah, we ran into a wall. But in space, we won't have any walls to run into. And the idea is just to build these, eventually these mega structures in space. And there's no way to do that other than to build it up there. You can't. Because
at the moment, it has to fit inside a rocket.
Yeah, exactly. We're constrained by the rocket, but in the future, that constraint will be lifted for spacecraft designers and satellite designers with the technology to be able to build it up there instead.
Yeah, there'd be huge things. So I just want to go back to the moon, and you've got a 3D printer the size of a microwave at the moment on the ISS, and I understand the scaling problems of having to keep it small. But building a launch pad on the moon, that's going to be huge.
Yeah, so sort of like our satellite printer, we've developed printers that aren't just boxes, and everything doesn't have to fit in a box. We've done a lot with robotics and really innovative systems so that you can build structures and tools much larger than the printer itself.
My 3D printer at home works it's like a hot melt glue gun, so it gets hot and then the plastic dribbles out under gravity. You haven't got that pull in space. So how are you actually making these things?
Yeah, exactly. Our first printer used a very similar technology. So it's very similar to the printer you have at home, and printing a polymer through a hot end. And there were quite a few things we had to deal with when adapting it for space. But one is we couldn't rely on gravity. And so we modified the system so that the material didn't fall because it would just bubble up into a big ball. We worked on a way where surface tension would dominate and pull the material to our print bed and then let it cool and it would stick there. And then each layer would then kind of pull to the print bed. And the other big challenge with printing in space is the thermal profile. So heat doesn't rise or kind of move through convection normally. It sort of pools in one spot. And so we had to really work on the thermal systems within the printer to make sure the heat was moving where we wanted it to.
So otherwise you could end up with a bit of molten plastic in one place and a solid lump in the other.
Exactly. Yeah, we take some things for granted that we have down here on Earth.
What was the first thing you sent up to the space station?
The very, very first print was pretty interesting. It was a piece of the printer. So we printed a panel on the printer itself, really to kind of tell that story where, in the future when we're on Mars and starting to build workspaces millions of miles away, we can have these self-reliant systems where the 3D printer not only is printing parts to fix everything around it, but it can actually replicate itself and print itself.
And you've also sent up tools for the astronauts.
Yeah, quite a variety of tools, both for inside the space station as well as for EVAs or spacewalks outside the space station. One of the first tools that we printed was a ratcheting wrench. So it was all printed as one assembly, but it was actually 3 parts working together, and the ratchet would, turn in one direction but not in the other. And we built that for an astronaut who requested it, and we were able to design it and deliver it to him in about a week's time, which is incredibly fast for space station standards.
Oh, that's great. I now want to print that. Can you send me the files? Could I print it, please?
Yeah, absolutely. We'll send you the file and you can print it at home. And we've had thousands of people over the years print this wrench at their house.
Fantastic. Thanks ever so much, Matt, for joining me today.
Yeah, thank you.
I'm in the middle of printing the wrench that Matt sent me the designs for. So I downloaded them and put them into some slicer software on my computer. That just means that the 3D model that I downloaded can be sliced so that my 3D printer can actually read it and knows what to do with it. So how my 3D printer works, and a lot of the home 3D printers, is there's a reel of material, PLA in my case, of sort of plastic, and it's about 2 mil diameter, and that is fed into a nozzle, and that melts the plastic just like a hot glue gun, and the plastic then dribbles out the nozzle. This is going to take quite a while to finish, so I think I'll come back in a couple of hours and check on it. I heard the printer finish a little while ago, so I've left it to cool down, and now I've just come back to see what I've got. And it just looks like a wrench. It's a socket that you'd get in a socket set. It's a little bit shorter, and it's bright red plastic because that's the material that I had. Let me just take it off the base. Oh, it's actually quite tactile. It fits just in the palm of my hand. There's little hand fingerprint parts on the handle, and where the square bit where I'd normally put that into a socket of my socket set, that looks like it should turn, but it's not at the moment. I can't twist it with my fingers. Let me get a spanner on that. Oh yeah, when the 3D print layer's built up, there will be a very thin connecting layer to make sure that it was in the correct place, everything inside was in the correct place. So this has actually just come off the 3D printer and it's ready to use. There's no assembly required. The moving parts inside, now that I've snapped those little connectors, it's moving. So that's just turning in one direction. And yeah, if I try and turn it the other direction, I can't do that in the other direction. So that little lever is working brilliantly. Yeah. So this means that when I put pressure in one direction, it's going to hold, and it's actually going to allow me to do up the socket, but I can then bring it back and it goes dee-dee-dee-dee-dee, as it doesn't put any pressure in the opposite direction. What a lovely little socket. 3D printing a brand new tool is very cool, and it means I could repair something specific without ever having to leave my house. But would having a 3D printer really help astronauts in their everyday work? How useful is it to be able to make an object on demand when you're up on a spaceship? Luckily, I know just the person to ask. Samantha Cristoforetti is an astronaut with the European Space Agency, and she has spent almost 200 days living on the International Space Station. Hi Samantha, thanks ever so much for joining me today.
Hi Lucy, yeah, thanks for having me.
I know you were on the space station for over half a year, and I know that the space station is effectively a closed system. What was it like living in that closed system for all that time?
I know that one of the things that raises quite some interest usually when I talk to, people about my space flight, and there's usually a little bit of a reaction of disgust, is this fact that we actually recycle our urine. And, as we like to say, we turn yesterday's coffee into tomorrow's coffee. But, what I tell people is like, that's the same thing that Mother Earth does for us here on the ground, right? I mean, I'm sorry to say, but those water molecules in your glass of water probably have been somebody else's pee at some point in their life cycle. So, you don't even think about it. At least I did not in that sense.
Now, I'm a maker. I like to make things with my hands, electronics or craft or whatever. What tools did you have up on the International Space Station?
So we have quite a big toolbox with all, the typical do-it-yourself tools that, a maker like you would probably have in your house. Obviously, we don't have things like, laser cutters and everything like that. It's really all the supply of handheld tools we do have.
So was there anything that you needed that wasn't there?
Well, occasionally you lose things. I mean, a little bit of drama was at some point early in the mission, we lost the wrench, the ones where you really set your maximum torque, so you're sure that you do not over torque your fasteners. And so basically we lost the one that had the most common setting for our fasteners. And so we, the one we would use it all the time. And we basically had to fall back on other ones that kind of, if you combine those, then you could kind of cover the range of the one that we lost. And it showed up like months later. All of a sudden, we finally found it. And it was like, we couldn't believe it that for so long it had gone missing. Because we thought, okay, it must have been trashed somehow. It's probably burnt up in the atmosphere by now. It went back by mistake in some vehicle that burnt up. But it was actually on station, and we eventually found it.
But I assume if there was something you really needed, you'd have to ask for Earth to post it up.
Yes, definitely. So what we do on space station is to kind of oversupply at least the things that are most commonly used. We would have hopefully 2 of them, or as in the case of this torque wrench, you have kind of like a fallback option because, as you say, we cannot just go out and buy new ones.
And how long would it take to get something from Earth?
It depends. I mean, it depends when the next vehicle comes up. If it's something really urgent and you are lucky and something is flying up soon, then they might get it as an urgent cargo, which requires a lot of work. I mean, it doesn't just happen like that, a
they
cargo
can't just
item.
sling it in the back.
No, and especially, those things have, their processes, they take time. And if you want to do something last minute, it requires a lot of work by a lot of people. So,
The 3D printer wasn't up there when you were up there. But how do you think it will change and has changed since your time, actually having that availability of that printer?
Actually, believe it or not, the very first one was up there when I was up there. It was 2015. And it was, again, the very first one. It was about demonstrating that, the process, this extrusion process works at all in microgravity. And the idea was to compare the mechanical properties and see if microgravity made it in any way worse or, who knows, even better. You never know. You might be lucky. But it's funny because we did have that wrench story going on. And so Butch Wilmore, who was the one who mostly used the 3D printer, I think he was chatting with the guys and said, it would be great if we could just print a wrench like that.
Oh, that was the wrench. So that was the piece that you went missing.
Well, they ended up printing a wrench. Of course, it wasn't a torque wrench. It wasn't out of metal. It was more like out of the fun of it. And so they were like, "So what would you like?" And he joked us like, "I'd really like a wrench." So they printed that. But again, I mean, that was the baby steps, right? The very early model, and again, plastic with no... I mean, there's plastics out there that have very good mechanical properties, right? It wasn't the case on that early model. But, in the future, I think right now they have more advanced models on board. And also from ESA's side, we're planning to fly a metal-based one. So those, of course, are game changers, because then you can really print parts that have the mechanical properties you need for tools, for example. Mm-hmm.
Yes, I can imagine that that's really going to help things, and you won't have to have quite so much redundancy.
Yeah, that's kind of the point, right? I mean, to simplify the whole logistics. And we're not worried so much about space station. I mean, space station has a solid logistics chain, and it's really around the corner, right? It's in low Earth orbit. But when we're thinking beyond LEO, so beyond low Earth orbit, then it's a completely different story. Then we have to be much more careful, efficient, thoughtful about what we fly, because we will not have that much up mass. And also the volume available. I mean, space station is huge. People sometimes don't realize how much space, real estate we have up there. And still, it's quite full anyway. So, with much smaller vehicles in the future, we cannot just fly more and more tools just in case. So 3D printing eventually will be a big help, I think.
And you must, I suppose, be also looking at the recycling up there. Because at the moment, right, you throw the rubbish out and it burns up in the atmosphere, yeah?
Yes, that's what we do. Yeah, that would be perfect, right? I mean, that would be the ideal situation. And, we're still quite far from that. But ideally, one day, that's what you want to do, right? You just want to have your stock of raw material, your 3D printer, and then your shredder afterwards. And then you should be able to recycle the raw material. And then you just... Again, we're back to where we started, but talking about closing the loop.
So do you have a bin day up there at the moment? Is there, it's Thursday, it must be time to throw the bins out?
We don't have bins, we have trash bags. And believe it or not, trash management is a big deal. So again, there's people on the ground who keep track of how much trash bags we've used, and they make sure that we have enough volume in whatever disposal cargo vehicle we're going to use. They do a rough estimate of the mass of the stuff that is in that specific trash bag, because they need to figure out, depending on how you've loaded your vehicle, where the center of mass is going to be. Or the opposite, they need the center of mass. Actually, that's what mostly happens, right? You need the center of mass of the vehicle to be in a certain range. And so they will have to make a plan of where to put all that trash in the vehicle to make sure the center of mass ends up where it's supposed to be.
So they know that it will burn up and it won't come down.
For example, or if pieces do come down, they come down, I don't know, in the middle of the Pacific Ocean and not on our cities.
I'm thinking of the future and going further than low Earth orbit. And at the moment, I know astronauts go through an awful lot of training for what there is already up there. But I suspect at the moment, if you've got a problem, you can just phone Earth and say, we have this problem, can you help? But if you're further away, are we going to have to rely more on the astronauts to work things out for themselves?
Yes, I think this maker type that you mentioned earlier, I think we'll definitely need that type of person in the crew, probably more than we do now. I mean, now it's more about, you do need some mechanical skills. I always joke that, I'm an engineer, I studied engineering in college, but probably the most useful things that I learned in those years in terms of being able to be a crew member on space station were more like, working in the workshop and with tools, which is something that I did on the side as an internship and as a job, more than learning how to solve how to do your calculus. But you're not required right now to really necessarily come up yourself with a way of doing things, of repairing things, because there's procedures and there's experts on the ground and so on. So yes, looking long-term, deep space missions, the issue, of course, is communication. You will not eventually, if you're flying to Mars, eventually you'll get to the point where you're far enough that real-time communication is just not going to work very well. And so that ability of being able to tinker and to come up with some solution with what you have available, I think will become more important than it is right now on space station.
So there's hope for me yet to be an astronaut.
Yes, no, definitely. And all those maker types out there, it's definitely the way to go.
Samantha, thank you ever so much for your time today.
Yeah, thank you. It's been fun.
It's one thing trying to imagine what it's like to be up on the space station, but another to actually speak to someone who has been there and ask them, what was it really like? And for me, some of the most interesting things that Samantha said was how they do rely on the experts back down on Earth, and that they're really not encouraged to take them MacGyver, fix anything yourself. But when they head off to further afield, even the moon, maybe to Mars, that's when that creativity, that problem solving, that ability to make anything from anything, that's really going to come to the fore. And in the future, makers are going to be up in space. The next frontier is where you have to be self-sufficient. One of the things that really amazed me when I was talking to Matt from Made in Space is that he's working on a 3D printer to use moon dust. How useful would it be to use your surroundings as printer ink and make anything you could think of? So that's got me thinking, can I 3D print with earth dust, dirt? So I'm heading to my workshop to see what I can do with some concrete. I've got my sand, I've got my cement, I've got my ballast. I have got a piped icing bag because, that's how I'm going to 3D print. So my idea is to make up some concrete and then using the piped icing, make like a coil pot. So make sausages around and around and around, like a snail all the way around, the size of a coffee mug or something, just to see, is it possible? Can I do it? Got a bucket. Okay, so now get that in the piped icing bag. In some cement goes. Okay, squeeze! Oh my goodness. So it's all squidgy around, but I've had one droplet come out, and that's not because that's not because of I can't squish it. I can squish it in the piped icing bag really quite easy, but to squeeze it out the nozzle, that's not going anywhere. So concrete is thixotropic. So sometimes it acts like a fluid and sometimes it's really quite solid. If you've ever used corn flour and played with corn flour, and you know that if you stir it really gently, you can stir it, but if you thump it, it hurts your hand. That's the same thing that's going on here. The way I'm going to get around that is I'm going to agitate my concrete. And the way I'm going to do that is with an electric toothbrush. Okay, in it goes. Now, this just looks great. It stopped. There's too much. Oh, I've broken it. Electric toothbrush is not going to happen. However, I still have concrete in a piped icing thing, so I am going to lob the toothbrush inside the piped icing bag and just spin it by hand and see if I can get anything out. Can I get anything? No. Just no, I can't get a single thing out. I'm glad I'm not on the moon. Trying this is all I can say. attempt at printing concrete didn't work, which just goes to show how tricky it is working with materials. All the more impressive, I think, that people are working to develop ways to 3D print moon dirt. But what other materials might they want to print in the future? Is 3D printing going to be limited to plastic and objects or something else? To find out, I'm giving Tommaso Ghidini a call. He works for the European Space Agency. Tommaso, thank you very much for joining me. Would you mind just introducing yourself and your work, please?
Oh, of course. I'm the head of the Structures, Mechanisms and Materials Division. So we develop the technologies that will support and make possible the future missions of the European Space Agency.
And I believe one of those materials and mechanisms, I suppose, is 3D printing.
Yes. At the European Space Agency, we are manufacturing and launching very soon the first additive manufacturing machine to be used on the space station.
I thought we already had a 3D printer on the space station. What is it that you're sending up soon?
Yeah, so we do have 2 3D printers. One has been brought back, though they are polymeric, so they are plastic 3D printers. Mm-hmm. What we do now is we are sending up a metallic 3D printer.
Ah, right, yeah.
Yeah, but the on-planet utilization of 3D printing does not end here and also on the space station. That is, we are now looking into a Mars manned mission. Now, this opens to a completely different scenarios. That is, going to Mars requires at least 2 years. So in 2 years, although you will select the astronauts for being extremely healthy, of course, something can happen. You can have a burn, you can have a fracture of a bone. And so what we are now developing are also technologies to be able to, if you allow me the term, to repair the astronauts. So we have already 3D printed human skins, human bones, using stem cells, human veins.
As we're not just limited to plastics and metal, we're actually going to 3D print human bits so that we can fix our astronauts. So these astronauts that are going, they're going to have to, at least the early ones, they're going to have some kind of MacGyver approach of being able to solve every problem.
I think that's the right definition. So a kind of a MacGyver medical doctor that should be able to treat the majority of the emergencies. But again, you need to think that those people will be selected based on a very solid health condition. So what we want to do there is we want to have at least the technology for curing the accidents or the effects of an accident, say, for example, a burn. Now, printing skin is state of the art on Earth. And what we are doing now is defining what will be needed to bring that technology on a space mission. That could be another enabling aspect of having a mission with human beings, long duration, long distance in space. Of course, we are very cautious, meaning we are not dreaming of reproducing an organ tomorrow. What we are doing here is we are defining a serious roadmap to get eventually to that level of technology, being able to repair the astronauts, starting from skin, because it's easy, it's a patch, so you don't need surgery, going to the bones that requires a higher level of surgery capability. And now what to have is also a 3D bioprinter on the space station. Why is that? Well, because we want to study tissues that are grown on space, that are manufactured on space, to then simulate the effects of space on those tissues that are human. So before exposing the human beings to those level of radiations or those level of microgravity, and even defining medical treatments specifically for that patient on that particular mission, space mission.
Absolutely fascinating. We're going to select our astronauts for being very healthy before they go off to Mars.
Yeah.
Do you think things like creativity, design, and making skills are going to be almost as important?
I think creativity, especially for an explorer, is fundamental. So our astronauts are our explorers. They need creativity also to capture the scientific opportunity. That's why we're not sending only robots. We could do significant amount of missions, purely robotics, but we don't do that. We want to have human beings there because of their creativity. Say, for example, you are on a jeep trip on the desert and you break your wheel. Now, the fact that you have with you the spare part, hence the wheel, does not necessarily mean you will be able to repair it, because maybe the wheel and the structure of the car is so damaged that you cannot extract it anymore. You cannot remove it anymore. So you will need specific tools to be able to dismount the broken wheel. So 3D printing on a mission to Mars will give you that opportunity, will give you the opportunity to reproduce the spare part, first of all, but also to manufacture these and design on demand tools that you never imagined you needed.
Tommaso, what sort of timeframes are we looking at for some of these things?
Well, you see, many people think that we are still in a kind of a research and development phase. We are not. We are already flying it. We have a significant amount of missions coming up now that will have additive manufacturing baseline.
Wow, yes. And how about the printing biological stuff in space? When will that be?
So the biological stuff in space is also something that is coming up. We are now defining the requirements to have a 3D bioprinter in space. We are talking about few years still to go, and then we will have a biological printer in space. Consider that on the space station, we have even printed a steak, meat from a cow. The steak was printed based on stem cells. And again, imagine on a long-term mission what it means. You can have proteins.
Oh, wow, yes.
Proteins with you that you have in a reactor without bringing the cows with you and without bringing a developed meat. You print it. And by the way, that reactor that you use to develop a meat, you can use it to develop a part of an astronaut, the skin, the bone. But also, even further, you can use that technology to produce organs of human beings that you can implant in the human beings without having to wait for a donor. It's your stuff. It's your stem cells. So you will have no rejection.
Amazing. Absolutely amazing. Tommaso Ghidini, that's been absolutely wonderful. Thanks ever so much.
Thank you. It was a pleasure.
I'm back in my workshop and it's going to be another late night tonight. And I'm looking up at the moon and thinking about the future of space travel. And it feels like everyday tech of the 3D printer really does have a role to play. And the idea that you could 3D print tools, metals, buildings, even skin and body parts, it just means that we're not going to have that umbilical cord back to the Earth all the time, that astronauts are going to be able to go further, explore more, and do more stuff because they can 3D print. My work here is done. Time for some ice cream. The Engineering Edge was a Why Did the Chicken production for Design Spark. It was hosted by Professor Lucy Rogers and produced by Tiffany Cassidy, with Dan Page as the executive producer. Special thanks to our guests Matt Napoli, Tommaso Ghidini and Samantha Cristoforetti. If you enjoyed listening to the show, please do 3 nice things for us. Subscribe, rate us on iTunes and tell a friend. For more episodes and bonus content, head to designspark.com/podcasts.